Well, here are the quiz answers for chapter 3. This would be quiz number 2 or 3 for you. And make sure you learn this as much as possible for the exam, because you have some really important questions. The first one talks about a ball thrown with a velocity of 25 meters per second at an angle of 37 degrees above the horizontal. What is the vertical component of the velocity? You know that a vector can be resolved into two components, and if you take the angle with the x-axis, then you're going to get the horizontal component as whatever the vector is, which is in this case 25, cos of the angle. So here it's 25 cos 37, and the vertical is 25 sine 37. And that's because if you draw a triangle here, right here, you get a right angle triangle. This is going to be the opposite side, and the opposite side is what defines the sine. This is the adjacent side, and that's what defines the cosine. So in this question, the vertical component is just 25 sine 37. Find the value of sine 37 multiplied with 25 and you get 15 meters per second. Second one, if you walk 6 kilometers in a straight line in a direction north of east, and you end up 2 kilometers north and several kilometers east, how many degrees north of east have you walked? The most important thing here is to know that when you say north of east, you start with the east and you go to the north. So this is the east direction, and from there if you go to the north, this is what you would get. So you walked 6 kilometers along the straight line, and that is north of east, and you ended up 2 kilometers north, so which means this is 2 kilometers and several kilometers east. So you do not know how much this is, but this is what is given, right? So that's the 2 kilometers. Okay. So BE is 2 kilometers, AB is 6 kilometers, and you're asked to find theta. Sine theta is opposite side by hypotenuse, which is 2 divided by 6. And you get 0.33. When you take the inverse or the arc sine of that, you get 19 degrees. Again, sine theta is defined as opposite side by hypotenuse. That's why sine theta is 2 by 6, which is 0.33. Now to find theta, you take the inverse of that, you get 19 degrees. Number 3. A butterfly moves with a speed of 12 meters per second. The x component of its velocity is 8 meters per second. And you have to find the angle between the direction of its motion and the x-axis. So in this case, the speed is given and the x component is given. So that's the speed. That's the speed, which is 12 meters per second. And that is the x component, which must be 8 meters per second. And you're asked to find this angle. Okay, so the angle is theta. That's 12, that's 8. To find the angle, you take, okay, that's the horizontal component. If you take the cos of that angle, you know you would get 8. Because remember, the horizontal component is 12 cos theta. And if there was a vertical, it would have been 12 sine theta, which we don't need in this case. All we need is 12 cos theta is equal to 8, from which cos theta is 8 by 12, which comes out to be 0.6666, and take the arc sine of that, and you get 48.2 degrees. Number 4. Two vectors A and B have components 0, 1, -1, 3 respectively. What are the components of the sum of these two vectors? See, when you have a question like this, just remember that this is the x and this is the y. So this is the x component of the first vector, the y of the first, x of the second, y of the second. And all you got to do is add the two x's together and the y's together, which means you're going to get 0 plus -1, which will be -1, and 1 plus 3, 4. Therefore, the components of the sum of these two vectors is just -1 and 4. Fifth one. A car travels 20 kilometers west, then 20 kilometers south. What is the magnitude of its displacement? Before I draw the diagram, let's say you start from somewhere here and you go 20 kilometers to the west, and then from there you go 20 kilometers to the south, and you're asked to find this. Okay, there it is, 20 to the west, 20 to the south, and you're asked to find AC, which is the displacement, because displacement is from the starting point to the finishing point. And by the Pythagorean theorem, you get AC squared is AB squared plus BC squared, and that gives you 800, and therefore AC would be square root of 800, which is 28 kilometers. Sixth one. Two forces are acting on an object, as shown in the figure. What is the magnitude of the resultant force? The word resultant means the sum of the two vectors. So here is the figure must be given. So there is the figure there that was given to you. So that's the first force and that's the second. These two angles have been given. So first what you do is break this force into its two components. You will get an x and you will get a y. Do the same with this force, which will have an x component and a y component. The two y components are going to be in the same direction, which is upwards. But you see that the x components are in opposite directions. So just label them F1x and F1y, F2x and F2y. What's F1x? It's going to be 120 cos 60. Which is 60. F1y is 120 sine 60, which comes out to be 104 newtons. Now again, F2x is 80 cos 75, which is 21, and F2y is 80 sine 75. See how that works? Which is 77 newtons. So now find the total x component, which is one minus the other because they are in opposite directions. That's 39. But when you come to the y component, you add the two because both of them are pointing in the same direction. And when you add them, you get 181 newtons. And then to find the resultant of the two, you use the Pythagorean theorem, and you get 185 newtons because the total x and the total y are at right angles and they form a right angle triangle, of course. Okay, so the answer is 185 newtons. Number 7. A stone is thrown horizontally. That's an important word. with an initial speed of 10 meters per second from the edge of a cliff. A stopwatch measures the stone's trajectory time from the top of the cliff to the bottom to be 4.3 seconds. What is the height of the cliff? What's important here is the word thrown horizontally, which means that its initial vertical velocity is 0. Because you project it completely along the x, it has no initial y component for the velocity. And what do we know about the horizontal component of the velocity? It never changes. So the speed of 10 meters per second, which is the horizontal speed, is never going to change. But at the same time, the initial velocity vertically, which was 0, is going to have an acceleration due to gravity. So that's the cliff. That's the trajectory of the stone. Delta y is what's the height, which is what you have to find. Okay, initial along the x is 10, along the y is 0. Now, y has an acceleration 9.8 meters per second squared. Delta y, got to find time is given as 4.3 seconds, right? What is the equation we could use? The king. And simply plug it into that. And this factor is 0. The whole thing becomes 0 because V0 is 0. And you get 91 meters. And there's something that's not been asked for. Delta x has not been asked for. And you could have found it out. Remembering that the velocity is constant. Therefore, the displacement is the product of the velocity multiplied by the time, which is 10 times 4.3, which is 43 meters. See, one of the answers is given as 43 meters to mislead you. That is the horizontal displacement. So in your head, you need to keep the horizontal and the vertical independent of each other. That's the key to doing these problems. Number 8. A jumper in the long jump or the broad jump goes into the jump with a speed of 12 meters per second at an angle of 20 degrees above the horizontal. How long is the jumper in the air before returning to the earth? Alright, diagram, that's how it goes. That is a 12 meters per second at an angle of 20 degrees. And you got to find the time. You break up the velocity into two components. You get the vertical as 12 sine 20 and the horizontal as 12 cos 20, which I've not written. And remember, in this case, delta y is 0 because he lands back exactly at the same level, which is on the ground. So he's not gone anywhere vertically. That's why delta y is 0. Okay, it lands back on the ground. We got to find the time. We know it is negative 9.8 because you only look at what happened at the beginning and it was slowing down in the beginning, right? So use this equation. Delta y is v naught t plus 1/2 at squared. And you get the answer. This is not a quadratic equation because you have a 0 here. You just got to change the sides and, change these two sides and solve. One of the t's will get cancelled and t will be 4.1 by 4.9, which is 0.84 seconds. Then, the ninth one. A projectile is launched with an initial velocity of 60 meters per second at an angle of 30 degrees above the horizontal. How far does it travel? Again, break it up into its two components, vertical and horizontal. The horizontal would be 60 cos 30 and the vertical would be 60 sine 30. Which is 30 meters per second. And then A is negative 9.8 for the vertical component. T, we're trying to find. Delta y is 0 because it lands back on the ground. Use this equation to find out time. just as in the last question. And once you get the time, remember that the horizontal component of the velocity is constant, and therefore the only equation we can use is multiply the x component with the time to give 318 meters. Very important problem. Number 10. A plane has an airspeed of 200 meters per second due north and is in a wind of 50 meters per second to the west. Well, the plane speed relative to the ground is how much? Okay, 200 meters to the north and 50 to the west. It's kind of drawn to scale because if this is 200, this got to be a little bit more smaller, 50. And you're asked to find the resultant of the two, which is this vector. That is the plane's speed relative to the ground. And that is just using the Pythagorean theorem. Such an easy thing, just square both sides, add them up and take the square root. When you take the square root of that number, you get the plane speed relative to the ground as 206 meters per second. Now remember that this is due north and this is due west, and all you got to do is find the plane speed relative to the ground. Brings us to the 11th one. The driver of a motorboat that can move at 10 meters per second in still water wishes to travel directly across a narrow strait in which the current flows at 5 meters per second. At what angle should the driver head the boat? See, the driver wants to go from here to here, but the water is flowing down. So, if he wants to get here, he must take off at a certain angle, at this angle upstream, because he's going against the current. So you got to find this angle, because now we know that his speed combined with the speed of the water gives you the resultant. Look at that. His speed, because he goes that way, the water is flowing this way, and you get the resultant as this one. Now that's 10 meters per second given. The current is at 5, and you got to find theta. When you're looking for theta and you see a right angle triangle here, what is this side? Is this the adjacent or is this the opposite? It is the opposite side. So you got to take sine theta is opposite side divided by hypotenuse, and that will give you the angle. In this case, it's 5 divided by 10, 0.5, and you take the arc sine, or the inverse of 0.5, you get 30 degrees. Okay, I'm trying to say that this is the boat's actual motion. This is how the boat is trying to go. Will not manage to do that because the water keeps carrying it down. So this is the boat's actual motion. Last one. A swimmer heading directly across a river. See, this time the difference is that the swimmer is heading directly across. The river is 200 meters wide and reaches the opposite bank in 6 minutes 40 seconds. She is swept downstream 480 meters. What's the speed of the current? Okay. So the swimmer goes directly across but will not reach there. Instead will go along this path because the current will take him down. So now we know the numbers. That's the velocity of the river, velocity of the swimmer. That's why I have Vs and Vr. You see delta y and then you have delta x. So you have both. Delta x is given as 480 meters. That's how much was swept downstream. That's, oh, sorry. Okay, got to do that again. Okay. All right. Touch the wrong places, and that's what happens anyway. So that's 480 meters. This is 200 meters. See, in this case, there's no acceleration either along the x or the y. So the only equation we can use is displacement is velocity multiplied by time. And so 480 is Vx times 400. And the time is 6 minutes, which is 360 seconds plus 40, 400 seconds, right? So Vx is 480 by 400, which is 1.2 meter per second. That is the speed of the current. And we're only concerned about the speed of the current. All right, thank you, and I hope you study this properly, nicely, and try to understand this, because you're going to see this on the exam. Thank you.